Have you heard about the BODMAS rule in mathematics, wherein the operators have a priority? We solve first division. First we solve bracket, then division, then multiplication, and then so on. So the operators have a hierarchy, right? Now C has a similar concept, but quite different from mathematics. In C, there is a priority or precedence or hierarchy given to operators. Now let me write the hierarchy of operators. In C, you have to solve that operator first. So the first operator in any expression, if it contains that operator, you have to solve that first. So the highest priority is given to the NOT operator. After that, in the second level of hierarchy, we have multiplication, division, or modular division. In the third level, you have to solve plus or minus, addition or subtraction. In the fourth level of hierarchy, you have relational operators: less than, greater than, less than equals to, greater than equals to. After that, you have relational equality, double equals to, and relational inequality. Then you have the AND operator, after that the OR operator, and then the least priority to be given is to the assignment operator. Now this is the priority which C follows. So this is increasing level of hierarchy, right? So just to remember, whenever you solve any expression or whenever you write a program which deals with expressions, so this priority needs to be maintained, needs to be taken into consideration. But the first and the foremost thing in an expression to be solved is bracket. So bracket enjoy the topmost priority. First you solve bracket, then other. Let us turn our attention to expressions now. Expressions are of different types. If that expression contains logical operators, then it's a logical expression. If it contains arithmetic operators, it's an arithmetic expression. Same as with relational, and there are a lot of various types of expressions. Now if you don't know, an expression is nothing but something which contains operators and operands, right? Now taking the example of arithmetic expressions, which are expressions which involve arithmetic operators. Now arithmetic means mathematical in the sense. Now maths has its own way of handling operators, and it defines its own symbols. Now C cannot use mathematical symbols because there are some limitations, like division cannot be represented in plain text, right? So C has some workarounds. Now so you have to convert mathematical expressions into C expressions. Let us take a few examples here. So we have algebraic expressions and their C expression equivalents. So A into B minus C, so the into sign is represented by asterisk in C. If we have P plus Q multiplied by P minus Q, so in maths you assume that here it is multiplication, even if you don't write it, but you have to tell explicitly in the C language if there's multiplication or not. If you drop this sign, it will show an error. AB by C is represented by A into B divided by C, right? 9x square, so there is nothing like square in C language. You cannot have exponential terms, so you have to manually write them. So x square is 2 times x, so 9 asterisk x into x. So this is the way it is. Okay, now let us look at a simple term called as associativity. Associativity comes to the rescue when you have confusion upon which operator to operate upon first. Consider this expression x equals to 2 into 6 by 3. Now there is a confusion between which to solve first, multiplication or division, because in the C priority level, multiplication and division are on the same level of hierarchy. So which to solve first? Here comes associativity to your rescue. Associativity is nothing but a way to solve an expression. Now associativity is something related to operators only. Now when you take multiplication or division operators, you solve them left to right. You take the left operand and then the right operand. On contrary, if you take the assignment operator, you first take the right operand and then put it into the left operand. So this is associativity, the way of solving an operator, using an operator. Now the associativity of multiplication and division is left to right. Now you must be wondering how associativity will help us. Now let us take each operator and list its left operand and right operand. So if we take multiplication, left is 2 and the right operand is 6 by 3. If we take the division operator, the left is 2 into 6 and right is 3, right? Now if you look at it carefully, which is the most non-confusing operand, which does not have confusion? The left operand of the multiplication is not confusing because it's a constant. It is not, no operation needs to be done, right? And for division operator, we have the right operand as not confusing. Now what is the associativity of these multiplication or division? Multiplication is left to right, division is left to right. So the one whose left operand is not confusing because its associativity is left to right, whose left operand is not confusing will be solved first. So naturally multiplication will be solved first, right? Because its left operand is not confusing, non-confusing operand. Then only one operator remains, so x equals to 4. Let us take another example here. If a is equal to b is equal to 51. Now here is also a confusion of which to solve first, because equal to and equal to obviously same priority, right? Now considering this first equal to, left is a, right is b equals to 51. Unambiguous means not confusing is left. If this equal to is taken into consideration, the left is a equals to b, right is 51. Now equals to is the associativity of equal to is right to left. So which equal to would be solved is whose right operand is unambiguous. So this equal to will be solved first, then this equal to. Now let us solve this expression. Var equals to 10 minus 12 divided by 3 plus 3 into 2 minus 1. So the first and the foremost thing is to solve the parenthesis, solve the brackets first. So the innermost brackets will be solved first, right? You do the same thing in mathematics, right? So 3 plus 3 would be solved first. What remains is the second inside bracket, but the insides of the second bracket contain some ambiguous operators, right? So here division and multiplication, so the left would be solved first. We learned this earlier in associativity, right? Left operator first. Then the parenthesis, again the left operator first, right? Because minus and minus enjoy the same priority, so the left operator first, because the associativity of minus is left to right. and done. Var equals to 5. Now 5 will be assigned to var. Okay, now look at a little concept of type conversions. Type conversion is nothing but the conversion of one data type to another. If we have two incompatible data types, we have to convert one of them, right, for operation between them. Now we have learned this earlier in this lecture also. Int gives an integer, float gives float, int float gives float. Now any one of the operands is a float, that gives float. So if operation is 3 by 2, result is 1. Why? Because it involves two integers, right? If it's 2 by 3, result is 0. Because it involves two integers, it gives the result as integer, and the decimal part is truncated, the floating point part is truncated, right? If any one of them is float, the result is float. That's all we have in this slide. Now that was type converting automatically. The compiler automatically type converts it. But there arise some situations where you have to manually type convert it. Right? So if you take this example, you first declare a floating point variable var, then you assign var the value of 7 by 2. Now a normal person would go on by saying that var will contain 3.5, but let's look if it contains 3.5 or not. This is an operation between integer and integer, so the result will be an integer. 7 by 2 is 3.5, the decimal part is truncated, so we get 3. Output is 3.00. Where is the 5? So in such cases, this is wrong, right? In such cases, what we'll do is type convert manually. So float var and var is 7 by. Now we will convert 2, which is an integer, to float by preceding it with a float. This is the way to type convert. We are converting one of the operands to a floating point number. So this time we'll get a perfectly correct value, absolutely correct value, 3.5, which is correct. Now this can be, there are approaches how you can convert one of the values to floating. You can write 7.0 by 2.0 or 7 by 2.0 or float in brackets 7 by 2, and there are several other ways. Now a final concept remains, which is of storage classes, which is very easy concept. But before you know what are storage classes, you must know this. Where do computers store data? Now there are two types of places where computers can store data. One is memory, another is CPU registers. Memory is nothing but RAM, and CPU registers are nothing but a type of memory which is inside CPU. Now RAM is slow memory because it is contained in a different chip. CPU is in another chip and RAM is in another chip, so it takes time for the signals to flow between them. Now CPU registers are directly contained inside the CPU, so they are the fastest memory available. Now RAM contains a lot of memory. It is unimaginably vast for your program, right? And CPU registers are limited in number. Now here comes storage class. This is important for you to know, right? And storage class. Now storage class, there are 4 types of storage classes: automatic, register, static, and external. Now why do we need storage classes? They tell us about the storage, right? We looked at the storage in earlier slide, memory or register, where to store the data of that variable. They tell us about the initial values. When you declare a variable, what value it will contain. They tell us, storage classes tells us the initial values, the life and scope. Now initial value is nothing but the value which is first contained in a variable when it is declared. When a variable is declared, it may contain garbage value or it may be 0, right? And we talked about life and scope. Scope means you declare some variable in one part of our program, and if you want to access it from some other part of our program, then you cannot access it because it is limited. Its scope is limited. Now scope is nothing but a term which tells us that in which part the data cannot be accessed, in which part of the program the data cannot be accessed. Now let us look at automatic storage class. Now take this program void main. You declare an auto int, automatic integer variable, a and b. You declare two variables and you print the value of these two variables. So first time you run the program, you might get this value 25 and 8. The second time you run this program, you might get another value. The third time you might get another value. So these values are not fixed. These are called garbage values. Now the initialization is garbage value for an automatic integer variable. Now let us look at the scope of variable. Now B scope, let us say we have, this is a program segment. Now in braces define the scope. In the outer braces we have declared an integer a, and a equals to 10. We have assigned a value 10 to a, and thereafter we create a pair of braces again, and inside that we declare another variable b and assign the value 15 to a inside. So b scope is defined by these braces because b is declared inside these two braces, and a scope is defined by these two braces because a is declared in these two braces. Now this operation a equals to 10 is successful because this statement is within a scope, right? And it is within a's block. If you consider this statement a is equal to 15, this is also successful because this statement is also within a's block. Why? Because this is inside a's block. It is also inside b's block, but yes, it is inside a's block, so it is eligible for this statement, right? Now if you assign a value 4 to b or any other value to b outside b's block, outside b scope, so it is not possible because it is not in b's block. So what I wanted to tell you is nothing but that scope is important in programming, right? Now if you say normally int, we have declared variables in our programs which we wrote previously, we just declared them as int. Now int is nothing but an auto int. You don't have to explicitly write auto. If you write, it's okay, the program runs. That is, auto is the default storage class, right? Now auto variable, auto integer, auto float, auto character, or any other automatic variable is stored in stack memory, is in a part of memory which is called a stack memory, which is inside RAM, not inside CPU registers. Its uninitialized value is garbage, right? When you declare it, it is undetermined. The value cannot be determined. It can be anything. The scope we looked at is defined by the block in which it is declared, right, within the braces. The lifetime is inside block. Once the control goes outside the block, you cannot use the variable, right? The variable dies after the control goes out of the block. Life and scope are very closely related terms. Auto is the default storage class, we know this. Now there comes register storage class, which is similar to auto storage class. The only difference is that register storage class the variable is assigned the memory, is given the memory inside the CPU registers. Differences that stored in CPU registers, right? Keyword is register. If you want to declare a register integer, so you write register int a comma b, or in this way. Now, what is the use of declaring a variable as a register? We know that CPU register is very fast. Now, when you need a variable most frequently, then that variable you should declare it in register, because the access time will be reduced. So you declare the variable which is most used in the CPU registers. Now, CPU registers are limited. What if CPU registers are not free? Then in such a case the variable is treated as an auto variable. Now, a register variable is stored in CPU registers. The uninitialized value is garbage. The scope is within the block, similar to the auto variable. Lifetime inside the block, same as an auto variable. Now, there is another type of storage class known as external storage class, also known as global variables, right? They are stored in data memory. Now, your program is divided into stack memory, data memory, and a lot of program segments. Now, in those divisions, global variables reside in data memory, actually in RAM. Now, when you declare an external variable or a global variable, it is always initialized to 0, right? When you don't initialize the value, it gets automatically initialized to 0. The scope is global. It is accessible to all functions, or it is accessible in all parts of the program. And the lifetime is until you end the program. Those live on. You can access till the end of the program. Now, the last type of storage class is static storage class. The variables declared are called static variables. These are also stored in RAM or the data memory. Uninitialized value is 0. The scope is local to a block, similar to what we saw in automatic variables. But the lifetime is retained between function calls. Now, what are functions, what are function calls, we'll study in some other videos, but the lifetime, you should remember that static variables lifetime is that it is retained within function calls. Now, you have a choice of choosing a storage class. Now, when do you choose auto, register, external, or static? External or static. Now, auto, when it is a default class, it is used in most of the cases. You use register when the variable is accessed most frequently, right? To reduce the access time. External if it is required in the whole program. It is required by all functions of your program. Static when the variable's value is to be retained between function calls. When you call a function, and when you return from that function, when the control returns from a function, the value should be retained. We'll study that. We'll study static and external variables in some other video lectures, but for now remember these things.